This video will go over section 4.1 inverse functions. Question number 1 asks us to decide whether the function graph is one-to-one. Well, a one-to-one function passes what we call the horizontal line test. So we need to say, does this pass the horizontal line test? You're familiar with the vertical line test to determine if a graph is a function, but a horizontal line test will tell you whether the function is one-to-one. Now that means if you draw a horizontal line through the graph, that it will only go through one point at a time. So this function, we could say, yes, it is one-to-one. Another way of thinking about whether a function is one-to-one is if it has any repeated repeated y values. In other words, is there a y value for two different x values? In this case, there's no repeated y values. It does pass the horizontal line test. We say that this graph, this function is a one-to-one function. Okay, question number 2. Decide whether the function is one-to-one. This is the equation y equals 2 times the quantity x plus 1 squared minus 6. Now, if you remember how we graphed this in the previous chapter, this is a graph of a parabola, and this parabola has been transformed by shifting the whole parabola to the left 3, so our vertex is -3, and this -6 indicates that the parabola has a vertex at -3, -6. And if you plot that point, and the 2 indicates that you have a narrow parabola, and it's positive, so the parabola opens up. So you have a parabola that looks something like that. That's a really quick, rough sketch. Now, once you get the sketch of the graph, see if it passes the horizontal line test. If you draw a horizontal line, it's actually going to go through 2 points here. So it does not pass the horizontal line test. So what that means is that this function is not one-to-one. It's not a one-to-one function. Okay, so we can check our answer here. Now you could also do a quick sketch. If you have a graphing calculator, look at the graph on the calculator and see if it passes the horizontal line test. So I've entered the equation y equals 2 times the quantity x plus 3 squared minus 6 into the graphing calculator. And if you start off with a zoom standard, you can see the shape of the graph here. Looks like my quick sketch here. And if you draw a horizontal line, it's going to go through more than one point at a time. So we say this function is not one-to-one. Okay, let's look at number 3. In number 3, we're asked to use a definition of inverse to determine whether f and g are inverses. The way I'm going to approach this problem is to start off with the function f of x and use the steps to finding an inverse. And you can refer to the instructor tip here for the steps for finding an inverse. The way you find an inverse of f of x is to replace f of x with y. So I'm going to have y equals 3x minus 15. And then I'm going to interchange the x and the y. So where I see a y, I'm going to write an x. And where I see an x, I'm going to write a y. Everything else remains the same. The third step in finding an inverse is to solve this equation for y. I'm going to do that by adding 15 to both sides. And you get x plus 15 equals 3y. And then we're going to, that should be a 15, sorry. And then we're going to divide both sides by 3. and then you get the y by itself. So y is equal to x plus 15 over 3. Let me write that up here. So again, we have y equals x plus 15 over 3. And the last step is to replace y with the symbol for the inverse, which is f inverse of x equals x plus 15 over 3. Now this can be written another way. You can divide both of these terms by 3, and that will give you x over 3, x divided by 3, plus 15 divided by 3. 15 divided by 3 is 5. Now notice that this is the same thing as our g of x function is the same thing as our f inverse of x function when you simplify it. So the answer to the question, are f and g inverses of each other? We can say yes. And check our answer. So yes, they are inverses. For question number 4, this is a similar question. Use the definition to determine whether f and g are inverses. Again, if we go to those 4 steps for finding an inverse, we're going to start off with our f of x function. We're going to replace the f of x with y. And then we're going to interchange just the x and the y. Everything else stays the same. Where you see a y, you're going to put an x. And where you see an x, you're going to put a y. And then we're going to solve this equation for y. I'm going to subtract 11 from both sides. And we get x minus 11 equals a negative 3y. And then we want to divide both sides by negative 3. And we get x minus 11 divided by negative 3 equals, the negative 3 divided by negative 3 is 1, that's y. So let me write that up here. I get y by itself equals x minus 11 divided by negative 3. And we're going to replace the y with f inverse of x. That's the notation that is used for inverse function. And we can divide each of these by negative 3. X divided by negative 3 minus 11 divided by negative 3. We can simplify this just a little bit here, and we get a 1x divided by negative 3 is the same thing as a negative 1/3 x. And this minus 11 divided by negative 3 is the same thing as plus 11 over 3. Now compare this to our g of x function. Is this the same thing? Not quite. So since they are not identical or even equivalent, we can say that these are not inverse functions. These are not inverses. F and g are not inverse functions. Okay, check your answer. Let's look at number 5. For this question, we're given a function f, and we want to find f inverse of x. Well, remember when you're doing the 4 steps of finding an inverse, the second step is to interchange the x's and the y's. You're going to do the same thing when you're finding the inverse if you're given a list of points. So you're going to use squiggly brackets for the set. Now 4 comma negative 8 is a point on the original function. In the inverse, the x's and the y's are reversed. So reverse x's and y's. So the 4 negative 8 is going to be negative 8 comma 4. That's going to be a point on the inverse. 1 negative 1, that corresponds to negative 1 comma 1. And then negative 2 negative 3 becomes a negative 3 negative 2. Alright, so what I've done here is simply reverse the order of the x and y in each point, and that's a point on the inverse. We can list the points. Oops. And we separate those points with commas on MyMathLab. Can separate with commas. And the last point was -3, -2. So that's how we find the inverse if we're given points. If we're given the equation, you follow the 4 steps. If you're given the set of points, you simply reverse the order of x's and y's.